A good day to Dr. Haika and to the audience. So today we from Group 4 Tuesday session and Group 1 Thursday session, we are going to present our topic with the title of the effect of glucose, fructose and sucrose intake on concentration of urinary sugars. And the equipment we use is UV spectrophotometer. So before we start our presentation, we would like to introduce ourselves. I'm Ewan from Group 4 Tuesday session.
I'm Farah from Group 1 Thursday session.
I am Muhammad Wazirkan bin Mubarak from Group 1 Thursday session.
I am Faiz bin Hassan from Group 4 Tuesday session.
I am Abdullah Adel, Group 1 from Thursday section.
I'm Muhammad Shadiq bin Muhammad Hatta from Group 4 Tuesday session.
I'm Muhammad Rafiq from Group 4 Tuesday session.
I would like to explain on our objective of our project. So the first objective is to investigate the concentration of glucose, sucrose and fructose in urine from affecting by different intake of beverage, which are Coke and water. And the second is to evaluate the validity of urinary sugar excretion as the indication of added sugar intake in diet. So these are basically our agenda for today's presentation. First one will be abstract, and second will be material and methods, followed by result and discussion, and the fourth one ending by conclusion and recommendation. So now we will continue with Abdullah for abstract.
So firstly, I will talk about the abstract, which our experiment that use period urinary sources, sucrose, fructose and glucose as a potential biomarkers for the concentration sugar consumption was investigated. And the general idea of our experiment is to monitor the effect, different amount of intake towards the concentration urinary sugars. This experimental was tested by 3 volunteers. Each volunteer has the same dietary as the others. And after finishing the limit of the time in the experiment, with the samples collected from each volunteer, and the results obtained showed that the dietary intake has affected the concentration of urine sugars, and urinary sugars appears to be valid biomarker for sugar intake.
I would like to explain the introduction for our project. Recovery of sugars in urine is a must criteria needed in order to validate the urinary sugars excretion as the indication for added sugar intake. Urinary excretion of each sugar can be compared with dietary intake of the corresponding sugar and added sugar intake during each feeding period. The concentration of urinary sugars can be detected using the UV spectrophotometer, and the amount of dietary sugars intake recovered through urinary excretion can be calculated using the absorption value taken from the UV device. The concentration of sugars is determined in terms of glucose, fructose and sucrose. Monitoring the sugars intake is important as it can be used as indicator for an early sign of sugar-related diseases such as diabetes.
For the material and method part, so for the first step, 3 subjects were required to follow the 7 days of control diet. They differed by the amount of canned Coke consumed. And second step, 24-hour urine sample was prepared to measure urine sugar morning to following morning. And for the third step, the urine sample were kept at room temperature, centrifuge to remove the protein aggregates. And for the last part, suitable wavelength were determined for glucose, sucrose and fructose. All the data obtained were recorded and tabulated.
So these are the results for our project. So before we can measure the concentration of sucrose, glucose and fructose, we need the calibration curve. So the first figure here will be glucose standard curve at 212 nanometer. And the second figure is sucrose standard at 580 nanometer. And the third figure over there is fructose standard curve at 258 nanometer. So each graph will have a linear curve, and the equation of the graph can be used to calculate the concentration, as the graph is absorbance versus concentration. So the data of concentration of each urinary sugar is tabulated in the next slide. So the first table will be glucose, and the second will be sucrose, and the third will be fructose. So overall, we can see that subject C has the highest concentration among the three subjects.
So for this project, we have subject A, B, and C. If we don't have these three subjects, so this experiment will not be as successful as we planned. So next, the main objective of this experiment is these three subjects take different dietary intake of sugars. So their beverage will not be the same because we want to measure the concentration of sugar. The first subject is subject A. He drink mineral water, and the second subject drink 1 can of Coke, and the last subject is subject C, which he drink 2 cans of Coke. So what is the main objective of this experiment? We want to measure the concentration of sugar, which is sucrose, fructose, and the absorbance value. For the glucose, sucrose, and fructose, as you can see on the screen, this screen, and the absorbance value is 0.06, 0.287, as you can read on the screen. Okay. For the result, the highest concentration in urine is the sucrose. Because of what? Because of fructose and glucose are mostly absorbed in human body. Why fructose and glucose is not as the same as sucrose? Because glucose and fructose are the primary sugars. As you can see here, the glucose and fructose is the monosaccharide, and the disaccharide is the sucrose. So glucose and fructose will form sucrose. Okay, next. As you can see there, the calibration curve standards, it is to predict the concentration of an unknown sample in the urine, and then the more intake of sugars, the higher the absorbance value, the higher the concentration of urine sugars. So what if you exceed the amount of sugars intake in your daily dietary intake? What happens? What will happen is it places a burden on your liver, which may lead to a series of metabolic problems. This is why I will explain on the percentage recovery of sugars in urine. As you can see here on the screen, we have the percentage of sugars recovery. As we know that subject C drank the most sugars in his dietary intake, but subject C has the least sugars recovered, which is 32.89%. Some errors occur during the experiment. The first error is the urine. When the urine is collected, some of the sugar intake is not fully hydrolyzed and excreted out of subject's body. This causes the percentage of sugar recovery in the urine to be low. The second error that might occur and has occurred is the subjects may have taken their food at different times. So these three subjects, they took their dietary maybe 1 hour late or 1 hour early. So that's why it will differ the result. And then the last error is when we measure the volume of liquid, there might be parallax error. Our eye is not perpendicular to the measuring cylinder. That's why this error might occur.
So I will be presenting on the limitation of study during our course of experimentation. There are 3 limitations that we encountered. The first one being that UV-vis spectrometer can only detect certain urinary sugars. For a better result, high performance liquid chromatography can be used. The second one, the sample size was small and lacked diversity. If more subjects are involved, the validity of this experiment of these biomarkers can be determined using ANOVA analysis. And the last one is that sugars might not be fully excreted from the subject's body when his urine was collected. This caused inaccuracy in result.
I will explain about the conclusion. So the spectrometer UV-vis is very useful to determine the quantitative and qualitative of analysis for both organic and inorganic. Next, sugar content, which are glucose, sucrose, and fructose in urine, are tested using this equipment. 3 subjects consume different sugar intakes, resulting in different concentration of urinary sugar. The higher the sugar intake, the higher the concentration of urinary sugar. it can be concluded that urinary sugar can be a valid biomarker for sugar intake. For the error prevention, make sure the lid of the UVs is properly closed so that no penetration light from outside. And then the cuvette used is to be make sure that it is clean, dry and has a smooth surface. And the most important thing is that make sure the subject follow the dietary plan strictly, so a better result can be obtained. And lastly, make sure the observer eyes is perpendicular to the solution level when it's taken. This is the reference we use during the experiment